Good afternoon to each and every one of you, and welcome to the session on data analytics. My name is Smith Shah, and I will be your mentor for today. I have been delivering trainings in the field of data science and AI since the past 7 to 8 years for multiple clients, including LTI, Capgemini, Deloitte, Accenture, and many more. So that was just a brief introduction about me. Now let's focus on our main agenda for today. So guys, today I'm going to explain to you what is data analysis, and with respect to data analysis, what all services does AWS offer. Before starting, I will just try to explain two important terminologies to you. So let's understand the difference between analysis and analytics. So analysis is like carefully examining something. I repeat myself. Analysis is like carefully examining something, such as data or a problem or an event, to understand its parts and what it means. It's a general process that anyone can do, often step by step, to figure out why or how something works. Analytics, on the other hand, is more specific. It's the use of tools, software, and mathematics to study large amounts of data quickly and find patterns, find trends, or do predictions. It's often done with computers in fields like business or sports to make smart decisions. So, what's the key difference? Analysis is the broader idea of studying anything in detail, while analytics is a technology focused version of analysis that's all about data and automation. Now, let's understand the benefits of big data analytics. So big scale data analytics, often called big data analytics, helps organizations turn massive amounts of stored data into useful actions. So instead of just collecting and storing data, which costs millions, analytics processes it to solve real problems. Let's understand the six main benefits in simple terms. First benefit is customer personalization. This means using huge data sets to customize experiences for individual customers. For example, by analyzing shopping habits, by analyzing browsing history, and by analyzing preferences from millions of users, companies like online stores like Zepto or Blinkit can recommend products that feel just right for you, making you more likely to buy and stay loyal. Second benefit is fraud detection. Big data analytics spots cheating or scams by scanning patterns in transactions across vast amounts of data. Think of it like a smart alarm for credit cards. If someone tries to make unusual purchases, example, buying expensive items in a new country, the system flags it instantly to prevent theft or financial loss. The third main benefit is security threat detection. This involves monitoring networks and user activities on a massive scale to catch dangers like hackers or viruses early. By crunching data from logs, devices, and traffic, analytics can identify suspicious behavior. Example, unauthorized access attempts before it turns into a big breach, thus keeping systems safe. Fourth main benefit is user behavior. Analytics dives into how people interact with applications, how people interact with websites or products by studying large scale data on clicks, time spent, and paths taken. This helps companies understand what users like or dislike so that they can improve designs like making a social media feed more engaging or fixing frustrating parts of an application. Fifth main benefit is financial modeling and forecasting. Here, big data is used to build models that predict money related trends like future sales, like stock prices, or economic shifts. By analyzing historical data from markets, economies, and companies, It helps with planning budgets or investments, thus reducing risks and spotting opportunities ahead of time. The sixth and last major benefit is real-time alerting. This benefit focuses on instant notifications based on live data streams. For instance, if analytics detects a sudden spike in website traffic, or a drop in sales, or a machine failure in a factory, it sends alerts right away so teams can react quickly, preventing small issues from becoming big problems. So basically, big data analytics isn't about hoarding data. In fact, it's about unlocking its value to make smarter, faster decisions in business and beyond. Now, please note that data analytics can be broken up into four types. First type is called descriptive statistics. I repeat, first type is called descriptive statistics. Let me do one thing. Let me highlight it properly over here by opening a annotation tool. So I will open an annotation tool on my screen. Let me do that. By the way, please note guys that today's lecture will be a theoretical based lecture only. We are not going to see any demo. Okay, I've opened a annotation tool. Okay, by the way, Sasanka Kumar Mohati has a doubt. Yes, Sasanka. Any doubt you have, you can mention it in the chat. You have raised your hand. So I'm assuming you have doubt. If you have any doubt, please mention it in the chat. If you have raised your hand by mistake, I would request you to unraise your hand. Anyways, but if you have any doubt, please feel free to ask the doubt in the chat. Anyways, moving on to our slide and let's continue our learning journey. So as I mentioned, data analytics can be broken down into how many parts? I repeat myself again, it can be broken down into how many parts, guys? It can be broken up into four types. First is descriptive analytics. I repeat, first is descriptive analytics. This type looks at past data to tell you what has already happened. It's like summarizing facts from history. For example, it could show you how many sales a store has made last month or how many visitors a website had yesterday. So it basically answers the question, what happened? The second type is called diagnostic analytics. I repeat, the second type is called diagnostic analytics. This digs deeper to explain why something happened. So it finds causes by looking at patterns or connections in the data. For instance, if sales dropped, it might reveal it was because of bad weather or a competitor's sale. So it answers the question, why did this happen? The third type is called predictive analytics. I repeat, the third type is called predictive analytics. This uses data from the past to guess what could happen next. So it makes forecasts based on trends, often with mathematics or statistics, basically, like predicting tomorrow's weather from today's patterns or how many customers might visit a store next week. So it basically answers the question, what might happen in the future? The fourth and last type is called prescriptive analytics. This goes further by suggesting the best actions to take based on the data. It recommends decisions to improve outcomes using simulations or rules. For example, it might advise a company to lower prices to boost sales or reroute trucks to avoid traffic. So it basically answers the question, what should we do next? So please note that data analytics is broadly broken down into these four types. First is descriptive analytics. Second is diagnostic analytics. Third is predictive analytics. And fourth is prescriptive analytics. Let's dive into these four types more. First, starting with descriptive analytics. So descriptive analytics is a straightforward way to examine data from the past or the present to identify patterns. These could be trends. Think about how things evolve over time or relationships. like how one factor links to another. For instance, it might reveal that sales increase during summer months or that website traffic spikes on weekends. Essentially, it's all about summarizing what the data tells us without diving into the why part or predicting what's next. Okay, so that's why it's often labeled as the most basic form of data analysis. It simply describes what's in front of you. It highlights those trends and connections, but stop short of exploring causes or forecasting outcomes. Imagine it like flipping through a history book and just reporting the key facts without analyzing the deeper implications. One of the best parts is that descriptive analytics is super accessible and user friendly. You don't need advanced skills or high tech tools. Basic charts or simple reports get the job done. In fact, your organization probably uses it daily. Things like reviewing yesterday's sales figures or monitoring website hits to get a quick sense of the current situation. So that was about descriptive analytics. Let's dive into the second type of data analytics, which is diagnostic analytics. Diagnostic analytics is basically the next level up from descriptive analytics. Diagnostic analytics is all about digging into data to figure out why certain things happened, like uncovering the root causes behind the trends or patterns that you have already spotted. For example, if descriptive analytics shows that sales dropped last month, diagnostic analytics helps you pinpoint why the sales dropped. Maybe it was due to a price hike, or maybe it was due to bad weather affecting foot traffic, or a new competitor is stealing your customers. So it looks at correlations, which are connections between different factors or variables in the data, such as how advertising spend links to website visits. You can think of it as a natural follow-up step after using descriptive analytics. Once you have identified that something interesting is going on, like a spike in user complaints or a dip in productivity, diagnostic analytics steps in to investigate and explain the why behind it. It doesn't just describe the surface, it probes deeper with techniques like data mining, statistical analysis, or drilling down into subsets of data to reveal those hidden relationships and causes. The third type of data analytics is predictive analytics. Predictive analytics is all about looking ahead. It's the process of using data to forecast future events and trends. Think of it as making educated guesses about what's coming next based on patterns from the past and present. This type of analytics is super important and plays a key role in many different industries, helping businesses, governments, and organizations plan better, reduce risks, and seize opportunities before they happen. What might surprise you is how often predictive analytics shows up in everyday life, way more than you probably realize. For example, it powers your weekly weather forecast, where models analyze historical weather data to predict if it will rain or shine tomorrow. It also drives advanced stuff like algorithm powered medical advancements, such as AI systems that predict disease outbreaks, patient outcomes, or even the best treatments based on tons of health data. Don't worry, we will see a implementation of predictive analytics, so it will become more clear to you. Okay, so once the theoretical part is done, I will show you implementation as well, a short implementation. The fourth type of analytics is prescriptive analytics. Prescriptive analytics takes things a step further in the world of data analysis. It's essentially about using data to figure out the best possible action to take in a given situation. Imagine you have got a problem or a decision ahead. This type of analytics crunches all the relevant information, weighs different options, and then suggests the optimal path forward. For example, in business, it might recommend the ideal price for a product to maximize profits. Or in healthcare, it could suggest the most effective treatment plan for a patient based on their data. What makes it so powerful is that it doesn't just tell you what happened or why, or even what might happen next. In fact, it actually provides actionable recommendations for your next steps. That's why over here, you can see in the slide, it highlights it as a valuable tool for data-driven decision making. It helps people and organizations make smarter decisions backed by solid evidence rather than just gut feelings. So those were the four different type of data analytics. Now, please note that data is generated in many ways. The big question is where to put it all and how to use it to create value or generate competitive advantages. The challenges identified in many data analysis solutions can be summarized by five key challenges. First challenge is volume. Second challenge is velocity. Third challenge is variety. Fourth challenge is veracity. And fifth challenge is value. Don't worry, I will explain all these five challenges in detail, right, in the next slide. But please note that not all organizations experience challenges in every area. Some organizations struggle with ingesting large volumes of data rapidly. Others struggle with processing massive amounts of data to produce new predictive insights. Still, others have users that need to perform detailed data analysis quickly over enormous data sets. So data volumes are increasing at an unprecedented rate, growing from terabytes to petabytes, and sometimes exabytes of data. Traditional on-premises data analytics approaches cannot handle these data volumes because they do not scale well enough and are too expensive. We hear from companies all the time that they are looking to extract more value from their data, but they struggle to capture the data, they struggle to store the data, and they struggle to analyze all the data generated by today's modern and digital businesses. Please note, guys, that data is growing exponentially. It's coming from new sources. It is increasingly diverse, and it needs to be securely accessed and analyzed by any number of applications and people. So companies have increasing data volumes and need to get the right data to the right people. Okay. And the last year, the year 2025, has shown us we need to prepare for change. So let's understand the data analytics challenges. Please note that data is a valuable resource for any organization, and it also presents various challenges. The five V's of data are volume, velocity, volume, velocity, variety, veracity, and value. They represent the main challenges associated with managing and analyzing data. So going forward, I will also give you an overview of each challenge. And along with that, I will explain the relevant AWS services that can help address them. But why do these challenges even matter? They impact business decision making and innovation. Okay. So let's understand the five V's of data analytics or the five problems of data analytics. First is volume. Volume is the massive quantities of data generated by businesses. It could be generated by institutions as well. It could be generated by individuals as well. So it causes challenges for storage, processing, and analysis. The second challenge is velocity. Okay. The second main challenge is velocity. So velocity is nothing but the speed at which data is generated and it needs to be processed. It requires real time or near real time analysis to provide timely insights and decisions. The third main challenge is variety. Okay. So variety is basically the different types of data that organizations manage, including structured data, semi-structured data, and unstructured data from diverse sources. So it requires effective data integration and analysis for comprehensive understanding. The fourth main challenge is veracity. Veracity is basically the quality, accuracy, and reliability of data. It highlights the need for cleansing and transforming processes to ensure that data integrity is good and it and we avoid coming to misleading conclusions. Okay. The fourth and last main problem is value. Basically, value is nothing but the ability to extract meaningful insights from data. It involves converting raw data into actionable information for data-driven decisions that lead to business growth and innovation. So these are the five main problems related to data analysis. Now, for each of the problem, AWS has created some services. Let's look into those. Let's focus on our first problem, volume. Okay. So AWS has three main services that help handle massive volumes of data. Think of these as your toolkit for dealing with big data challenges. First up, we have Amazon S3. That stands for Simple Storage Service. Now, what exactly is S3? Think of it as a massive digital warehouse where you can store pretty much anything. You can store documents, you can store photos, you can store videos, you can store database files, you can store application logs, you name it, you can store anything over here. The beauty of S3 is that it is scalable, meaning it can grow with your needs. You're not limited by storage space. The key benefits here are that it provides quick data retrieval when you need your files. And on top of that, it is extremely secure and it's durable, meaning AWS will not lose your data. Plus, you only pay for what you actually use. If you use 1 GB of storage, you only have to pay for 1 GB. If you use 5 GB of storage, you only have to pay for 5 GB. Okay. So when would you use S3? Well, it's perfect for storing your raw data files. It's perfect for storing your backups, your archives, or basically any data that you need to keep safe, but might not need to analyze right away. Okay. So this is the first service, Amazon S3. The next service is Amazon Redshift. Okay. So let's move on to this service, Amazon Redshift. So this is a completely different beast. Redshift is what we call a managed data warehouse, and it's built specifically for large-scale data analytics. Imagine a super-powered spreadsheet that can process petabytes of data. That's millions of gigabytes, incredibly fast. What makes Redshift special is that it's designed from the ground up for analytics. It can run complex queries on massive data sets way faster than traditional databases. And because it's managed by AWS, you don't have to worry about maintaining the underlying infrastructure. Okay. So why would you use Redshift? Think about running business intelligence reports, analyzing sales trends across multiple years, or creating real-time dashboards that pull from millions of records. That's where Redshift shines. Now, the third service to talk about is AWS Lake Formation. And this one is really interesting. Lake Formation is like having a librarian for all of your data. It helps you create what we call a data lake, which is essentially a central repository where you can store all your structured and unstructured data from different sources. The magic of lake formation is that it can conveniently organize all this data and make it available for wide ranging analytics. It brings together data from multiple places, makes it easy to find and use. It handles security and access permissions and simplifies what is normally a very complex process. So imagine you want to combine customer data from your website, sales data from your CRM system, and social media data all in one place for comprehensive analytics. That's exactly what lake formation helps you to do. Now, here's where it gets really powerful. These services work together beautifully. Okay. So let's suppose we have a rapidly growing organization with many terabytes of data that needs near real-time insights. So here's how we can use these services together. First, we would store all their raw data. Okay. First, we would store all their raw data in S3. Okay. First, we would store all their raw data in S3. Okay. That's your cheapest and most flexible storage option. Then we would use lake formation to organize and catalog all that data. Okay. We'll use lake formation to organize and catalog all that data, making it actually usable and accessible. Finally, we would analyze that data using Redshift to get those real time or to get those near real time insights that we need for business decisions. Okay, so you can see that this combination doesn't just address the volume challenge, It also tackles variety, velocity, and helps extract real value from all that data. But anyways, here I only wanted to focus on the volume part, that out of the five main challenges of data analytics, the first challenge is volume. And with respect to volume, AWS does have its own services. Now moving on to the second challenge, guys. Anybody remembers the second challenge? After volume, what's the second challenge, guys? What's the second challenge? Anybody remembers? Is my voice perfectly okay, guys? Can you let me know? Is my voice fine? My voice seems to be fine, right? Okay, fine. So here many students have given the correct answer. Okay. So after volume, in fact, few students have mentioned another challenge as well. Fine, not an issue. The answers given by you are all correct. Okay. It's just that in the chronology that we followed, after volume, the second challenge was velocity. But the other answers are also right. Those are also challenges that are mentioned by you, which we'll see going forward. But in the chronology that we mentioned earlier, the second main challenge is velocity. Okay. So now let's shift our gears and talk about velocity and the related AWS services. Remember, velocity is all about the speed at which data is generated and how quickly you can process it. In today's world, data is coming at us fast. Think of social media feeds, think of IoT sensors, think of financial transactions or website clicks. All of this is happening in real time and very fast. So let's look at four AWS services that helps you handle this data velocity. First, we will have a look at a service called Kinesis. So this is your go-to service for real-time data streaming. So what does that mean? Well, Kinesis helps you collect, process, and analyze data as it is happening in real time. Imagine you have thousands of sensors sending data every second, or millions of users clicking on your website simultaneously. Kinesis can handle all of that data flowing in continuously. The key thing over here is streaming. Instead of just waiting to collect all your data and then processing it in batches later, Kinesis lets you work with the data as it arrives. This is crucial when you need immediate insights, like detecting fraud transactions when they happen, or monitoring your application's performance in real time. Next up, the second service that I want to talk about is Amazon MSK, which stands for Managed Streaming for Apache Kafka. Now, Apache Kafka is an incredibly powerful open source platform for handling streaming data, and it's widely used across the industry. But here's the thing, setting up and managing Kafka on your own can be pretty complex and time consuming. That's where Amazon MSK comes in. It gives you all the power of Apache Kafka, but AWS manages the infrastructure for you. So you get a fully managed, highly available Kafka service that can securely stream your data without you having to worry about the underlying servers, or without you having to worry about the software updates, or without you having to worry about the underlying scaling issues. AWS will handle the infrastructure for you. So if your team already knows Kafka, or if you need that specific capability, then MSK is a great choice because you get the familiarity of Kafka with the convenience of AWS managing it for you. The third service that I want to talk about is Amazon EMR, which stands for Elastic MapReduce. EMR is what we call a cloud big data solution, and it's designed for processing massive amounts of data at petabyte scale. What makes EMR special is that it lets you use popular open source frameworks like Apache Spark, Apache Hive, and Presto. Think of EMR as a powerful processing engine. You can use it for interactive analytics, where you are querying and exploring your data, or for machine learning workloads, where you are training models on used datasets. It's incredibly flexible because it supports these well-known open source tools that many data engineers and data scientists already know how to. The beauty of EMR is that it can scale up or scale down based on your needs. So you're not locked into a fixed infrastructure. So when you need more processing power, you get it. When you do not need additional processing power, you scale down. Okay. Finally, we have another service for velocity, which is AWS Lambda. And this one is a bit different, but super important for velocity. Lambda is what we call serverless computing. Now, what does serverless mean? It doesn't mean that there are no servers. It just means that you don't have to manage them. You simply write your code and AWS handles all the infrastructure. Lambda is perfect for event-driven applications. What's an event? It could be a new file uploaded to S3, or a new record in a database, or a new message in a queue, or data coming through Kinesis. Okay. So basically, Lambda automatically responds to these events and runs your code. So here's why this matters for velocity. Lambda helps you quickly respond to changing data and events without managing any infrastructure. As soon as something happens, boom, your code executes. It's incredibly fast and it scales automatically. So if you have one event per minute or 10,000 events per second, Lambda handles it beautifully. So here's the powerful part. All of these services that we saw on this slide often work together in a data pipeline. Let me paint you a picture. Imagine that you are in a rapidly growing organization with real-time data streaming in. You might use Kinesis or MSK to capture all that streaming data as it arrives. Then you could use Lambda to process individual events instantly, maybe cleaning the data or triggering alerts. For heavier processing and analytics on large batches of that streaming data, you would use EMR to run complex computations using Spark or Hive. Okay. So you see Kinesis and MSK handle the data ingestion and velocity. Okay. I repeat, Kinesis and MSK handle the data ingestion at high velocity, whereas Lambda provides instant event-driven responses and EMR gives you the horsepower for serious data processing and analytics. Okay. So that was the second challenge, velocity, and I showed you the services available in AWS for it. Now, guys, what is the third challenge that we saw in data analytics? First was volume. Second was velocity. What is the third one? Third one. Here there's a participant by the name SN who has mentioned it. He has mentioned that the next one is variety, right? Even Ashwini has mentioned the same. Even Sai Ramdev has mentioned the same. That the third challenge in data analytics is variety. So let's talk about variety and the related AWS services. So when we talk about variety in data analytics, we are talking about the different types and formats of data that your organization deals with. See, you have got structured data like spreadsheets and databases with neat rows and columns. Then you have unstructured data like emails, videos, and social media posts. And then you have got semi-structured data like JSON files or logs. The challenge is, how do you store and analyze all these different types of data? Well, AWS has specific services designed for different data varieties. Let's go through them. First up, we have Amazon RDS, which stands for Relational Database Service. RDS is your managed relational database service and is designed specifically for structured data. What does that mean? Where structured data is the traditional database stuff. Think of it like customer records or inventory list or sales transactions data that fits neatly into tables with rows and columns. So if you have structured data, then Amazon RDS is the service to go for. The really nice thing about RDS is that it supports multiple database engines. So whether your team uses MySQL database engine or PostgreSQL database engine or Oracle or SQL Server or MariaDB, don't worry, Amazon RDS can handle it. And because it's managed by AWS, you don't have to worry about patching, you don't have to worry about backups, or you don't have to worry about most of the maintenance stuff. You just focus on your data and applications. So when would you use RDS? Anytime when you need a traditional relational database for your structured data, like customer database of an e-commerce platform or a content management system, then Amazon RDS is the one that you can go for. Now let's go to the next service, which is DynamoDB. So this is where things get more flexible. DynamoDB is a NoSQL database and is designed to be fast and flexible. Unlike traditional relational databases that require a fixed schema, meaning you have to define your table structure upfront. On the other hand, in DynamoDB lets you work with more varied, more semi-structured data. The key phase here is any scale. So DynamoDB can handle massive amounts of data and millions of requests per second. It's incredibly fast and it automatically scales up or down based on your needs. So when would we use DynamoDB? Think about applications that need to store diverse type of data that do not fit neatly into a traditional database structure. Maybe you are building a mobile app where user profiles have different attributes, or a gaming application where each player's data looks different, or an IoT application collecting sensor data that varies by device type. Don't worry, DynamoDB handles all of that variety beautifully. Now, moving on to the next service, which is Amazon Redshift again. But here, this time we are looking at it from a different angle, the variety angle. We talked about Redshift earlier as well as a data warehouse. But what's more important here is that Redshift is capable of processing petabytes of data for large scale analytics. And here's the key. It can handle data from many different sources and in various formats. Think about it this way. Your organization might have structured data from your databases, semi-structured data from application logs, and other varied data sources. Redshift can bring all of that together for comprehensive analytics. It's built to handle this variety and still perform complex queries quickly. So Redshift acts as a central place where all your different types of data can come together for analysis, regardless of where it originated or what format it was in. Finally, you have another service over here called Open Search Service. And this one's really versatile. Open Search is a search and analytics engine that's specifically designed to work with various data types. The key phrase here is diverse data sets. So whether you're dealing with log files, whether you're dealing with text documents or clickstream data or application monitoring data or security information, don't worry, Open Search Service can handle it all for you. What makes Open Search so special is that it's not just about storing data, it's making it searchable and analyzable. You can perform full text searches, run complex analytics, you can create visualizations, and even set up real-time monitoring and alerting. So why would you use OpenSearch? Think about scenarios like searching through application logs to troubleshoot issues, analyzing user behavior on your website, monitoring security events across your infrastructure, or even building a search feature for your application. Don't worry, open source excels at helping you search and analyze diverse datasets that might be difficult to query with traditional databases. Okay. So now let me give you a real world scenario where all of these services can work together in a complete data architecture. Imagine that there's a growing organization, okay, having lots of data. Now they might use RDS, okay, they might use RDS to store their structured transactional data. I repeat, they might use RDS to store their structured transactional data, things like orders or things like customer information. Okay. Then they would use DynamoDB for their mobile app data. Okay. Then they will use DynamoDB for their mobile app data. That's more flexible and it needs lighting fast access. All of this data, along with logs and other sources, could flow into Redshift. Okay, all of this data, along with logs and other sources, could flow into Redshift for comprehensive business analytics. And they might use OpenSearch to make all their log files searchable. Okay, to make all their log files searchable. And to monitor their applications in real time, basically. Okay, so that is how you could use these services together in a complete data architecture. Fine. Now, with this, we have talked about three main data analytics challenges and the related services offered by AWS. Moving on to our fourth challenge, guys. What's the fourth challenge? First was volume. Second was velocity. Third is variety. What is the fourth challenge? Anybody remembers the fourth one? Anybody remembers the fourth one? Veracity, right? Veracity. Okay. So let's go ahead and let's talk about veracity. Okay, and how it can be helpful for you. By the way, one student over here has a doubt related to our previous challenge, variety challenge. And with respect to that, I told you that there are some services offered by AWS. Out of those, one was open search. So let me explain open search again to you. Okay, so in which scenario it can be helpful to you. Okay, so basically, buddy, remember that open search is a search and analytics engine that's specifically designed to work with various data types. The key phrase that you have to remember, buddy, is diverse data sets. So whether you're dealing with log files, text documents, clickstream data, application monitoring data, or security information, OpenSearch can handle it all. What makes OpenSearch so special is that it's not just about storing data. It's about making it searchable and analyzable. So you can perform full text searches, run complex analytics, create visualizations, and even set up real-time monitoring and alerting. Now let me give you a picture again that how these services can work together. So let's suppose I'm in a growing organization like Zomato. Okay. So let's suppose I have some customer data or order data. So that data I will store in Amazon RDS. Okay. Because customer data and order data will mostly be in a structured format. So that structured data I will store in Amazon RDS. Okay. Then what about my mobile app data? Okay. So for mobile app data, what I will do is I will use DynamoDB to store the mobile app data. I can use a service like DynamoDB. Okay, that's more flexible and it needs lighting fast access. Now, all of this data along with logs and other sources could flow into Redshift. So maybe my logs, I could flow it into Redshift for comprehensive business analytics. Okay, so Redshift provides you capability to perform comprehensive analytics. Then what I could do is I can use OpenSearch to make all of my log files searchable. So the same logs that I stored in Amazon Redshift and I performed analytics on it. Now, if I want to make those log files searchable, okay, or if I want to monitor something in real time, then OpenSearch is something that I can go for. Okay, so I hope the usage of each of these services is clear. Okay, so if there's any doubt, you can still ask me, guys. Please feel free to ask your doubts in the chat. Anyway, so that was about our previous challenge that we addressed. Now moving on to our fourth challenge, right? As many of you guys have rightly mentioned in the chat over here, Ramdev has given the right answer. Ashwini has given the right answer, right? The next challenge, the fourth main challenge over here is veracity. Okay. So now let's dive into veracity and the related AWS services. So veracity is all about data quality, data accuracy, and trustworthiness. So here's the reality, guys. Okay, here's the reality. Not all data is created equal. You might have missing values in your data. You might have duplicate entries in your data. You might have errors in your data. You might have inconsistencies in your data, or you might have data that just plain messy. And if your data isn't trustworthy, your insights won't be trustworthy also, right? So it's garbage in, garbage out, right? You might have heard this phrase, garbage in, garbage out. If your data is garbage, then the insights out of it will also be garbage. So AWS has several services specifically designed to help you ensure that your data is clean, accurate, and reliable. Let's walk through them. First up, we have AWS Glue. And this is your core data preparation powerhouse. AWS Glue is what we call a fully managed ETL service. ETL stands for extract, transform, and load. What does that mean in plain English? Well, AWS Glue service helps you extract data from various sources, transform it, which means cleaning it up and getting it into the right format, and then load it into your data warehouse or your data lake. The key benefits over here are data cleansing and data transformation. So Glue can automatically find and fix data quality issues. It can handle things like removing duplicates, filling in missing values, standardizing formats, and ensuring that your data meets quality standards. And because it's fully managed, AWS handles all the infrastructure. So you just focus on defining how you want your data cleaned and transformed, and AWS Glue will do it for you. So think of AWS Glue as your data janitor. Okay, think of it as your data janitor. It takes messy, inconsistent data from multiple sources and turns it into a clean, reliable data that you can actually trust for analysis. Next, we have Amazon EMR again. Okay, but here we are looking at EMR through a different lens of veracity. EMR is that cloud big data solution we talked about before, and it's great for petabyte scale data processing. But what's more important for veracity is that EMR gives you the power to run sophisticated data quality checks and cleansing operations at a massive scale. So using open source frameworks like Apache Spark, Hive, and Presto, you can write custom data validation and cleansing logic. Maybe you need to check millions of records for consistency, or you need to apply complex business rules to ensure data accuracy. Don't worry, EMR gives you the processing power to do that across huge datasets. So while Glue is great for standard ETL tasks, EMR on the other hand is your go-to service when you need more customized, heavy-duty data processing and quality assurance at scale. Okay. Moving on to the next service, guys, which is Amazon Data Zone. So this service takes a different approach to veracity. Data Zone is a data management service that helps you catalog, discover, govern, share, and analyze your data. Notice the word govern here. That's crucial for veracity. Here's the thing. Ensuring data quality isn't just about cleaning the data once. You need ongoing governance. You need to know where your data comes from and where you can access it. What quality standards uh, it means and how it's been transformed. That's what Data Zone does. It helps you create a data catalog, basically an inventory of all your data assets with metadata about their quality, about their lineage and usage. It enables you to set up governance policies to ensure that data quality standards are maintained. And it also makes it easy for people across your organization to discover trusted data sources rather than using questionable data. So think of Data Zone as your data librarian and quality controller combined. It ensures everyone in your organization knows which data is trustworthy and which isn't trustworthy. Okay. Then the next service that we have is AWS Glue Data Brew. And this one is really user friendly. Data Brew is a visual data preparation tool. Okay, it's a visual data preparation tool and is designed specifically for data analysts and data scientists who might not be hardcore programmers. So instead of writing code to clean and normalize your data, you can use a visual interface that's available in Data Brew. So you can see your data visually, identify quality issues like missing values or outliers, and then apply transformations with just a few clicks. So if you want to remove duplicates, just click. If you want to standardize date formats, just click. If you want to filter out invalid records, just click. The beauty of Data Brew is that it makes data quality accessible to more people in your organization. So you do not need to be a coding expert to prepare high quality data for analytics and machine learning. It basically democratizes the data preparation process while still ensuring that your data meets quality standards. Okay. Now let's talk about how these services work together in a complete data quality strategy. Imagine a growing organization with many terabytes of data. Now, their data, the organization's data is coming from multiple sources. Some of it is clean, some of it is messy. Now here's how they might use these services. First, they might use AWS Glue to set up automated ETL pipelines. Okay. To set up automated ETL pipelines that clean and standardize the data as it arrives. Okay. Now for more complex and more custom data quality checks on massive data sets, they might use EMR. Okay. I repeat, for more complex and more custom data quality checks, you might use EMR, which is the second service that we talked about. Then you would use data zone to catalog all that data, okay, document its quality metrics and set up governance policies so that everyone knows which data sets are production ready and which data sets are not production ready. Okay, I repeat guys, over here using data zone, you can catalog all the data, document its quality metrics and set up governance policies so that everyone knows that which data sets are production ready and which data sets are not. And for ad hoc data preparation, maybe a data scientist needs to quickly clean a specific data set for machine learning experiment. In that case, they can go for data brew, okay, where they can visually prepare that data without writing a single line of code. Okay, so this gives you a no code approach to cleaning your data. So together, these services create a comprehensive approach to ensuring that the data veracity is maintained across data veracity is taken care of across the entire organization. Okay. So guys, this was the fourth main challenge, veracity. Now, anybody remembers the fifth and last major challenge of data analytics? Fourth one we have already seen. Fifth one has been mentioned by Ashwini. Ashwini has given the right answer. Fifth one is value, right? That's the fifth major challenge, value. So you can have all the volume, velocity, variety, and veracity you want. But at the end of the day, what matters is, can you extract meaningful business value from all that data? Can you turn that data into insights? And can you use those insights to make better predictions, predict outcomes, and drive your business forward? That's where these three AWS services come in. Let's explore them. First, we have something called QuickSight. So this is your business intelligence tool. QuickSight is a cloud-powered business intelligence service that provides interactive visualizations and insights to guide decision making. Now, what does that really mean? Think about it this way. You have collected all this data, you have cleaned it, you have processed it, but raw data is sitting in the database. But any raw data sitting in the database doesn't help anyone, right? To make decisions. So you will need to see patterns, you will need to see trends, you will need to see relationships. That's what QuickSight service does. It takes your data and turns it into beautiful interactive dashboards and visualizations. It creates charts, graphs, maps, tables that make complex data easy to understand at a glance. So business users can explore the data themselves, drill down into details, and uncover insights without needing to know SQL or any other programming language. Okay. The key phase over here is guide decision making. Please note that QuickSight service helps business leaders answer questions like what are our sales trends, which products are performing the best, where should we focus our resources, which customer segments are most profitable. Okay, so QuickSight is about making data accessible and actionable for everyone in your organization, not just data experts. That's how you extract value, by putting insights in the hand of decision makers. Next up, we have SageMaker. This is where things get really powerful. SageMaker is a comprehensive service for machine learning and artificial intelligence. It helps users develop, train, and deploy machine learning models to extract value from data. Now, why is machine learning so important for value? Well, traditional analytics can help you, it can tell you what happened in the past, your sales in the last quarter, your customer chain rate last year. But machine learning can predict what will happen in the future. and even recommend what actions to take. So with SageMaker, you can build models that predict customer behavior, detect fraud before it happens, recommend products to customers, forecast demand, optimize pricing, automate data quality control. Okay, the possibilities are endless. The beauty of SageMaker is that it handles the entire machine learning workflow. It provides tools for data scientists to prepare data, experiment with different algorithms, train models with powerful computing resources, and then deploy those models into production where they can generate real-time predictions. So when we talk about extracting value from data, machine learning takes it to the next level. It's not just about understanding what happened. It's about predicting what will happen and taking action based on those predictions. Finally, the last service that we are going to talk about is Athena. This service is brilliantly simple, yet incredibly powerful. Athena is an interactive query service that makes it convenient to analyze data in Amazon S3 using standard SQL. Here's what makes Athena special. It's serverless, so there's no infrastructure to manage for you, and you only pay for the queries that you run. Let me explain why this matters for value. Imagine you have terabytes of data sitting in S3 service. You have log files sitting there, you have transaction records, customer data, whatever. Traditionally, you would need to set up a database, load all of that data into that database, manage the infrastructure and so on, right? Now that would take your time and money. With Athena, on the other hand, you can start querying that data immediately using familiar SQL commands inside of S3 only. No need to transfer that data from S3 to any traditional database. From S3, if you want to query your data, you can do it by using your SQL commands, and that is possible by using Athena. So no setup required, no data movement, no infrastructure management. You just point Athena at your S3 data and start asking it questions. Let's suppose you want to know how many users visited your website from mobile devices last month. Write a SQL query, run it in Athena, and get your answers in seconds. Let's suppose you want to analyze patterns in your application logs. Query them directly in S3 with Athena. You'll get your answer in seconds. So this speed and simplicity means you can extract value from your data faster. Please note that business analysts don't have to wait days or weeks for data engineers to set up databases. They can get answers to their questions right now. That agility in accessing insights is incredibly valuable in today's fast-paced business environment. Now let's talk about how these services create a complete value extraction strategy. Imagine a rapidly growing organization one more time, wherein we have lots of data. Now, our organization has got their data infrastructure set up. Data is flowing in, it's being stored, clean, and organized. Now they need to extract value from it. So they might use Athena for quick ad hoc analysis. Okay, I repeat, they might use Athena for quick ad hoc analysis. A business analyst, let's suppose, wants to understand a sudden spike in website traffic. They can query the logs in S3 with Athena and get answers immediately. For regular business reporting and monitoring, they would use QuickSight, okay, to create interactive dashboards. Okay, they can use QuickSight to create interactive dashboards that executives and managers check daily. So let's suppose your sales performance, customer matrix, operational KPIs, all of it will be visualized and easily accessible over here. And for advanced analytics and predictions, they would use SageMaker. Okay, for advanced analytics and predictions, they would use SageMaker to build machine learning models. Maybe they would want to predict which customers are likely to churn so they can proactively reach out, or they want to forecast inventory needs to optimize their sales or to optimize their supply chain. So together, these three services turn data into different types of value. Descriptive insights with QuickSight service, quick answers with Athena service, and predictive intelligence with SageMaker service. Okay. So guys, these were the 5 main challenges of data analytics, and I showed you the different services available in AWS for these 5 services. So guys, that was the theoretical part. Okay. Uh, so I hope the basics of analytics are clear to you. Now, what we will do is, now that we have seen the theoretical part, let's see a short implementation. Okay. So as I explained to you earlier, there are different types of data analytics. I showed you four types, right? First was descriptive analytics, second was diagnostic analytics, third was predictive analytics, fourth was prescriptive analytics. Let's do one thing. Let's see implementation today of predictive analytics. Okay, let's see it. So what we'll do is we'll try to perform predictive analytics by creating a machine learning model. Before that, let me explain to you from scratch what is machine learning. Okay. So let me explain to you from scratch what is machine learning. So I'll open the relevant slide for that. Give me a moment. I'll just open the right slide for it over here. So there are four types of data analytics. Out of that, I'm showing you implementation of one type today. Okay, today we are not supposed to see the implementation as per our agenda, but I'm just showing it to you just for your reference. Okay, this is something extra that we are doing in this lecture. Okay, fine. So let me show you implementation as well. As declared earlier, today was just supposed to be a theoretical lecture, but since we have time today, it's better we see the implementation as well. Fine. So let's see implementation of predictive analytics. We'll create a model that does predictions using machine learning. So what is machine learning? Let's understand. So guys, machine learning is nothing but a set of tools which is used to get inferences through predictions. By inference, we mean insights. Now you might ask me that Smith, how do we get these inferences through predictions? How do we get these insights through predictions? Please note that we get it by using something called a machine learning model. So what is a machine learning model? It is nothing but a statistical representation of a real world process. Don't worry, I know the definition might have sounded complex to you. Don't worry, I will simplify it. In order to simplify it, I will take help of an example. Let's suppose I have some data of houses in my locality, and here is the information shown to you on your screen. Let's suppose we have information about area of the house in square feet, and I also have information about the price of that house. Let's suppose the first house that I surveyed had an area of 100 square feet and the price of the house was 1 crore. The second house that I surveyed had an area of 200 square feet and the price of the house was 2 crore. The third house that I surveyed had an area of 300 square feet and the price of the house was 3 crore. Now I have a question for all of you. Let's suppose I have information about a fourth house. The area of that house is 350 square feet, but I don't know the price of that house. So guys, according to you, what do you guys predict could be the price of this fourth house? Can anyone give me the prediction? According to you, what do you guys guess could be the price of this fourth house? So your Mohammed has given his prediction. He has rightly mentioned that according to him, the price of this house would be somewhere around 3.5 crore, right? Even Hemant has said the same thing. Even Vishwanathan, Rathina, Ashwini, all of you guys have said the same thing. That according to you guys, the price of this house would be somewhere around 3.5 crore. Now, guys, in order to arrive at this prediction, can I say that you use some mathematics in your brain? You use some statistics in your brain? Yes or no? In order to arrive at this prediction, you use some mathematics in your brain. You use some statistics in your brain. That's exactly what a machine learning model also does. A machine learning model also tries to use statistics or tries to use mathematics to simulate what would happen in the real world. Just like you guys tried to simulate the real price of the house by using some mathematics, by using some statistics. That's exactly what a machine learning model also does. It also tries to use statistics or mathematics to simulate what would happen in the real world event. Okay. Now, please note that in order to create a machine learning model, there are two important notes that you need to remember. First important note is, in order to create a machine learning model, we need some data, and that data needs to have some rows and some columns. Okay, that is note number one. Note number two is that there are only two useful type of columns in your data. First useful type of column is called a feature column. Second useful type of column in your data is called a target column. What's the difference between the two? Well, a feature column is a column that helps me to predict, whereas a target column is a column that I want to predict. So let's suppose I have some data with me. Now, looking at this data, let's try to understand what will be a feature column, what will be target column. I repeat myself, there are only two useful type of columns in our data. First useful type of column is called a feature column. Second useful type of column in our data is called target column. Feature column is a column that helps me to predict, whereas target column is a column that I want to predict. So guys, if I want to predict price, then price will be which type of column? I repeat myself, feature column is a column that helps me to predict, whereas a target column is a column that I want to predict. So if I want to predict on price, then price will be which type of column? Target column, right? As Ashwini has rightly mentioned in the chat, it will be target column. And since square feet and city help me to predict price, they will be called feature columns. Okay. Now, please note that there are different type of machine learning models. However, more than 95% of the work done in the machine learning industry is done on these two types only. So let's only focus on these two types for now. Okay, but please note that there are other type of machine learning models as well. But more than 95% of the work done in the machine learning industry is done on these two types. So for now, let's focus on these two types. The first type that I want to talk about is supervised learning model. The second type that I want to talk about is unsupervised learning model. What's the difference between the two? Well, a supervised learning model is a model in which the data that I'm working on has feature columns and target columns both. So if you're working on data wherein you have feature columns and target columns both, and on data you want to create a machine learning model, that model will be called a supervised learning model. Whereas if you have data wherein you only have feature columns but do not have target column, and you want to create a model on such data, then that model will be called an unsupervised learning model. So supervised learning model means model in which the data that I'm using has features and target both. Unsupervised learning model means a model in which the data that I'm using only has features but doesn't have target. Now, supervised learning models are further divided into two types. First is classification model, second is regression model. What's the difference between the two? Well, a classification model is a model wherein the target column has finite set of possibilities, whereas regression model is a model wherein the target column has infinite set of possibilities. Let's understand this with the help of an example. Okay. So let's suppose, guys, I have a column with me called dice roll. Let's assume dice roll column is my target column. Okay. Let's assume I'm playing a game of dice with my friends, wherein whatever value I get after rolling the dice, that value I'm storing it in this column. Okay. So let's suppose when I first roll the dice, I get the value 4. Again, when I roll the dice, I get the value 1. Again, when I roll the dice, I get the value 6. Again, when I roll the dice, I get the value 1 and so on. Now let's assume that this dice roll column is my target column. Now, if this column is my target column, then please let me know in this target column, how many possible values, how many possibilities do I have? Or in simple words, when I roll a dice, how many possible values can I get? Which possible values can I get? When I roll a dice, which possible values can I get? When I roll a dice, which possible values can I get? I can only get 6 possible values, right? When I roll a dice, I can only get 6 possible values. Either I can get the value 1 or 2 or 3 or 4 or 5 or 6. Apart from these 6 possibilities, I don't have anything else. That means when I roll a dice, I have 6 possibilities or finite set of possibilities. If dice roll column is my target column, that means in my target column, I have 6 possibilities or finite set of possibilities. And if in my target column, I have finite set of possibilities, then my model will be called a classification model. Let's take one more example. Let's suppose I have a column with me um, called gender. Let's suppose I want to predict the gender of an employee. Okay. And let's suppose I have some entries in this column. Let's suppose the first person for whom I have stored data had a gender of male. The next person had a gender of female. Next person had a gender of male, and so on. Now this gender column, let's assume is my target column. If this is my target column, then in this target column, do we have finite set of possibilities or infinite set of possibilities? You will say, Smith, here we have finite set of possibilities, right? In gender, we have only two possibilities, male or female. That means if gender column is my target column, you're saying in my target column, I have only two possibilities or finite set of possibilities. And if in my target column, I have finite set of possibilities, then my model will be called a classification model. Let's take one more example. Let's suppose I have a column with me called stock price, wherein I'm storing the price of the stock after every day. Let's suppose on the first day, the price of the stock was 99.48 rupees. On the next day, it was 98.1 rupees. On the third day, it was 100.7091 rupees, and so on. Now, if stock price column is my target column, then in this target column, we have finite set of possibilities or infinite set of possibilities. You will say, Smith, here we have infinite set of possibilities, right? Because my stock price could be anything. It could be 99.1 rupee, 99.17 rupee, 99.128 rupee, anything, right? So if stock price column is my target column, then in this target column, I have infinite set of possibilities. And if in my target column, I have infinite set of possibilities, then my model will be called a regression model. Okay. Ashwini has a doubt. Ashwini has asked to show a slide again. Yes, I will do that. Let's do one thing. I will do a quick revision of all these slides. That will be better for all. Okay. So starting with the first slide over here. First, I try to make all of you understand what is machine learning. So I said that machine learning is nothing but a set of tools that is used to get inferences through predictions. Okay. That means it is nothing but a set of tools that is used to get insights through predictions. Now, how do we get those inferences through predictions? How do we get those insights through predictions? We get it by using something called a machine learning model. What is a machine learning model? It is nothing but a statistical representation of a real world process. In simple words, we'll try to simulate a real world process by using some statistics, by using some mathematics. Now, please note that in order to create a machine learning model, there are two important notes that you need to remember. First important note is that for making a machine learning model, you need some data, and that data needs to have some rows and some columns. Second important note is that there are only two useful type of columns in your data. First useful type of column is called a feature column. Second useful type of column in your data is called a target column. What is the difference between the two? Okay. Feature column is a column that helps me to predict, whereas target column is a column that I want to predict. Okay. So let's suppose we have this data, and on this data, I want to predict on price column. Then price column will be my target column. And since square feet and city help me to predict price, they will be called my feature columns. Okay. After that, we looked into the different type of machine learning models. As I explained to you earlier, there are many type of machine learning models, but let's focus on two for now, because more than 95% of the work done in the machine learning industry is done on these two types only. So let's focus on these two types for now. First type is called supervised learning model. Second type is called unsupervised learning model. Well, a supervised learning model is a model wherein the data that I'm using has feature columns and target columns both, whereas unsupervised learning model is a model wherein the data that I'm using only has feature columns but doesn't have target column. Then supervised learning models are further divided into two types. First is classification model. Second is regression model. What is the difference between the two? Well, a classification model is a model wherein the target column has finite set of possibilities, whereas regression model is a model wherein the target column has infinite set of possibilities. Okay. Now, let's go ahead, guys, and let me show you how would you create a machine learning model. What is a machine learning model at the end of the day? A machine learning model is nothing but a statistical representation of a real world process. That means we'll use some statistics to simulate a real world process. That means we'll, in simple words, we'll use some statistical steps to simulate a real world process. Or in other words, we'll use a statistical algorithm to simulate a real world process. So you can either create your own statistical algorithm or you can use a statistical algorithm already available in the market. Let me use a statistical algorithm already available in the market called k nearest neighbors. Okay, called k nearest neighbors. Now you will ask me that, Smith, this algorithm is used to create which type of machine learning model, supervised or unsupervised? Please note that this algorithm is designed to create a supervised learning model. That means it will only work only if the data that you're using has feature columns and target columns both. Now within supervised, it is used to create which type of supervised learning model, classification or regression. Please note that it is used to create a classification model. That means it will only work only if the target column has finite set of possibilities. So the algorithm that I'm going to show you now will work only if the target column has finite set of possibilities. Fine. So let's suppose I want to create a model with this statistical algorithm called k nearest neighbors, which is also popularly known as KNN. Full form of KNN is k nearest neighbors. So if I want to create a model, I will need some data, right? Let's suppose I have my data. Let's assume I have three columns in my data: experience, age, and gender. Out of these three columns, let's assume the first two columns, experience and age, are my feature columns, whereas the last column, gender, is my target column. In fact, let's do one thing. Let me open a different slide where the example of data is more better. Okay, let me do one thing. I will open a different slide over here. Okay, fine. I will show you this example later because I guess that slide, um, I've used it for a different client. No worries. I can still proceed with the current slide only. No worries. Anyways, let's stick with this example only. That other example I will show it to you later. So as I mentioned that I want to create a model, right? Machine learning model using any statistical algorithm. Currently, the algorithm that I'll use is KNN. But let's suppose I want to create a model with any algorithm. I'll need some data for it. Let's assume I have data having three columns. First column is experience, second column is age, third column is gender. Let's assume the first two columns, experience and age, are my feature columns, whereas the last column, gender, is my target column. Okay. Now what I will do is, please note one important terminology, which is labels. What are labels? Labels are nothing but your target column values. So currently in my data, I have four target column values. I have four target column values. So that means I have four labels. And the rows having labels will be called labeled rows. Okay. The rows having labels will be called labeled rows. Anyway, so remember this term labels. If you ever see this term labels, it means nothing but target column values. So currently in my data, I have four labels or four target column values. What I will do is each row of data I will plot it onto the graph for better visualization of data. Let's do it. So while plotting, I will make sure that those points that have a gender of male are colored in red, whereas those points that have a gender of female are colored in blue. Let's do it. First, I'll take the values of first row of data plotted onto the graph. Similarly, I will take values of second row of data plotted onto the graph. Similarly, I will take values of third row of data plotted onto the graph. And likewise, I will take values of fourth row of data and plot it onto the graph. Now, let's suppose I want to make machine learning model on this data. Why would we create a machine learning model? So that we can use it to make predictions, right? Prediction is the end goal. So let's suppose I want to predict the gender of an employee whose age is 22 years and experience is 1 year. Okay. Now, this row that I have with me is an unlabeled row, right? It is an unlabeled row. I do not have a label assigned to it. So it's an unlabeled row. So let me plot this unlabeled row as well onto the graph. As Ashwini has rightly mentioned, it's an unlabeled row. So let's plot it onto the graph over here. Okay, fine. So let's create a machine learning model that helps me to predict the label of this unlabeled row, or basically that helps me to predict the target value of this unlabeled row, basically. Let's see. So what are the steps that will implement in this algorithm called KNN? You can use any algorithm that you like. Different algorithms have different advantages and disadvantages. Let's start with our first algorithm, KNN, also known as K nearest neighbors. First step is to choose the number of neighbors. Let's assume, just for the sake of example, that I chose number of neighbors equal to 3. Okay. Let's assume, just for the sake of example, that I chose number of neighbors equal to 3. Step number 2 is that depending upon the number of neighbors, we will select that many closest labeled data points with respect to the unlabeled data point. So here I have my unlabeled data point. With respect to this, I will select some closest labeled data points. How many? Well, it depends upon the number of neighbors. Guys, in my previous step, how many number of neighbors did I choose? In my previous step, how many number of neighbors did I choose? We assumed how many number of neighbors? 3, right? As Ashwini has rightly mentioned, 3 number of neighbors. That's why over here I will have to select three closest labeled data points with respect to the unlabeled data point. So with respect to the unlabeled data point, I will select three closest labeled data points. And you can see I've done that over here on your screen. With respect to the data point, I have selected three closest labeled data points. Now step number 3 is to make all of the selected labeled data points to vote. Red points will vote red, blue points will vote blue. Please note that will only make the selected labeled points to vote. I have selected three labeled points. All of these three labeled data points will vote. Red points will vote red, 2 points will vote blue. So 2 votes will go to red and 1 vote will go to blue. Then the last step is that based on majority of the votes, will assign a label of unlabeled data point. Here the majority of the votes will go to red color. That's why the unlabeled data point will also be labeled as red over here. And your red color stands for which gender value, guys? Male or female? Red color stands for which gender value? It stands for male, right? That means the unlabeled row will be given a label of male, exactly as estimated by you. Fine. Now you will have a doubt over here. You will say that Smith, fine, we understood the 4 steps of this algorithm, but out of these 4 steps, the first step was to choose number of neighbors. How do we know that? So for that, there is a general rule of thumb given, which is to use the formula square root of n divided by 2, where n stands for total number of rows in your training data. So let's suppose if I have 100 rows in the training data, then I'll just input this value 100. And that will give me an answer of 10 divided by 2, which is 5. Okay. So this is a general rule of thumb that you can follow. There are other techniques as well, but this is a general rule of thumb you can follow. Fine. So guys, understood that how looking at the data, you can use it to perform predictive analytics. Like that, there are different types. There were 4 types of analytics, right? Descriptive analytics, diagnostic analytics, predictive analytics, prescriptive analytics, 4 types. Out of that, I showed you implementation of one, which is predictive analytics. Okay. Up till here made sense, guys? Clear? I hope it was clear. If you have any doubts, you can ask. Anyways, guys, so today we were not focused on the demo part. Our entire lecture today was focused on completing the theory. Okay. In fact, our agenda was over half an hour earlier. It's just that I showed you implementation since we had extra time. Fine. Going forward, guys, we'll do many webinars like this. Okay, wherein we'll go into depth of a particular topic. We will be showing you demos as well, and different webinars. Today, our entire webinar was focused on just the theoretical part. Fine. Here one student is asking by which method you chose number of neighbors equal to 3. That I just assumed. I did not apply a formula, buddy. But I'm just telling you that going forward, if you work on any real world data set, maybe that formula you can use as a reference. Okay. Now there are many things to learn in machine learning. Okay. Please note that currently, can I say, Ashwini, that this number of neighbors is nothing but a setting in this algorithm? Can I call it a setting? Right? Setting. There's a setting in this algorithm. Now, settings are also known as hyperparameters. Another official name that we give to it is hyperparameters. So in machine learning, if you want to find best value for hyperparameter, we have hyperparameter tuning techniques. That's a separate topic. Okay, we'll not dive into that. But this is a general formula that I showed you, square root of n divided by 2. But if you tell me that, okay, on this data, why did I choose number of neighbors equal to 3? Just for example, I just uh, assumed a random number 3. Okay, I did not use any formula. I just assumed a random number just to explain a concept to you. Okay, anyways, this data that you see on a screen is not real world. That was just the example that I gave to you. Fine. All right. Fine. So that's it for today, guys.